Hey guys, me Rob with Open Machine Works, and I wanted to take a few minutes to make another solenoid engine video. I've had a few requests to kind of talk about the process that I'm going through, and I'm really excited to be doing it. So, I got my production done for the day. I got some of my production stuff going, and some other things. So I tooled up, and we're back to working on engine parts. So I have a block of 4" by 5/8 by 2" aluminum 6061, and we're making bases. This is a pretty challenging part to cam up, only because of these 3D chamfers. It is actually a chamfer, but it's I think it's called a compound chamfer, where it's constantly changing width and angle. Not sure how well it's picking up. And you can kind of see a tool path. That's because I'm ball tracking it. With a tool I had, I could not reach it. So I spent about 4 hours from, I know I started at like 9:30, and it was around midnight when I finally got it worked out. But these guys, and what it ended up being was a tool path that I did not know about. It was under the preview options called Blend. Super simple. You select a face or a drive surface and drive curves, and it generated in about 2 seconds. The toolpath is a little sloppy, some linking moves I don't like, but frankly, for what it is, I'm not the slightest bit worried about it. Just screw there. I think I just posted, yep, V3. So I've ran a few. I was able to speed up the surfacing operation. So I wasn't going to run it for you guys just because you might think it's a little boring, but you know what? If you don't like it, we can skip ahead and make sure we're torqued down good and tight. I have my Pearson Pro pallet covered up. See, we got a load V3 to V3 F2 memory, enter. Base op 1 V3 already exists. Do you want to replace? Yes, sir. Alright, calls up G54. All the tools look good. It's gonna get a little noisy because we run at 10K. Tool 19, show mill. Deck it off. Not going to turn off coolant because I want you guys to, or I want to get a decent finish. These do get tumbled. Now we're calling up tool 13, which is just a cobalt drill. 8,500 RPM, 30 IPM. Tool 4, IMCO 3H streaker. Now we're doing a 3D adaptive. It's a little ambitious. I need to work on my toolpath containment. And now what we're doing is roughing this out before I ball track it. I considered just going at it with a ball mill, but I did want a reasonably decent finish. While it's doing that, these are the parts that I've already finished and put through tumbling. Has some media stuck in there. Threaded half 20. Some marks that still need taken off down there from the Mighty Bite fixture. Not sure if I have that handy. But these engines will be shipping with a stonewash finish, which I think is just beautiful. I was just trying to find an alternate way to make them look nice, and that turned out to be it. I'm not sure how I'm going to do the crankshafts without damaging the precision surfaces, because they have a 5-degree focus, a 5-degree taper that locks in with a set screw, or a cap screw. There we go. Now we're just doing a boring up to do some counter boards. That would be these guys. I'm thinking we're gonna switch these to being open instead of closed off counter boards. My father's saying they'll look a lot nicer, so maybe we'll do that. But I want to get through his production run before changing anything. I'm too lazy to drill it, so we're interpolating it for a through hole. I wish that they had a next tool tab. Now we're going tool 18. That's a 2-flute Niagara ball mill. "65 inches per minute. Focus. I think it's set up, so those should be the correct parameters. You can turn off coolant for this. So, there are a lot of parts to this engine. You're gonna have to excuse the mess back here. We have the headstock, which is the part I showed you, the flywheel, I showed you that. We're working on the base right now. We need to make the main bearing support. Then I have to make the con rod, the crankshaft, and the, what do I call it? Linkage. But it makes for a real nice running engine. We do have a little bit of run out in the flywheel. And that's mostly by design. It needs to have some slop to run smoothly. Otherwise, we need to switch to bearings and the cost goes up. So, I mean, it's a quality model, but you do have to make some sacrifice for affordability. I just had it running a little bit, and it got pretty toasty. The whole thing acts as a little bit of a heat sink. And then we need to get the control board made. I actually just ordered the PCBs today that my father designed up. But as a transistor, resistor, 2 resistors. I know that he also put a diode on it to prevent a polarity switch. I'm debating shipping with a power supply. It's added cost, but because it is going to have a kind of a weird end on it, we're probably going to include one. We're looking at a price of about 150 bucks. I am going to be running a sale on the first run. My rounding tool, it makes, pardon me, it's made a lot of parts, thousands of these guys, and many, many thousands of parts. You can see once in a while I get a part loaded incorrectly and we get a bit of a burr, but we just finish it off with a Scotch-Brite. Now right here we're actually interpolating, you can't really see it, we're ball tracking that 3D surface. We're using a Melon 1/32 tool. I have the case right here. So there's a tool number. I think I actually have another one right here. If I can get it open one-handed without breaking it or stabbing myself. Dainty little tool. There's a crankcase, because I have those laying all over the place. So it has a press fit pin right there. That acts as a journal. And then this is all one piece to help maintain concentricity with a 5-degree taper that locks onto a 5-degree taper in the flywheel. Put this thing on mute. In case anybody had any concern for safety on these while we're right here. It has next to no power, so you're not going to get hurt on it and your kids won't get hurt. But there's a 5-degree taper in the flywheel. That one's a little dirty from tumbling, but that gets drawn on, and it runs very true to the journal. This thing is literally the culmination of 7 years worth of learning. Do I have one? Yeah, I do. So the first actual semi-production model I made, this one is very incomplete. You can tell because the flywheel's not, or the solenoid isn't even attached. You can see a video of it running on my channel. But that was my first solo project, and I was in cyber school when I started that. And I made all the parts on a router program with Bobcat, and it was a learning experience. The flywheels themselves took 59 minutes each. I remember the number. And there's that. The flywheels took 59 minutes each to make. And I would get one running on the router table, mind you, with an oil sprayer. I didn't even know about water-soluble coolant. And I'd hurry up and get one going, and I'd run back to class. And I had this whole long bar, like a 6-foot long bar along the router, and I'd feed it along and clamp it down with screws. I probably have videos somewhere on my Instagram of it. But we're getting a dang good finish there. That's just a Mori tool 90-degree rectangle. Here's that finish. It's not as good as it was even, because I just bumped it from 45 IPM to 65. And it was just taking too long. I'm trying to keep the cycle time down one. And it looks like I saved myself about a minute. Didn't eat my Wheaties. Yeah. Really had that thing cranked down. So that's first up. You can see these precision alignment holes set down here. So those mesh up with these and an 1/8 inch pin, and that ensures that these stay aligned and can't rock at all if the screw were to happen to come loose. And it actually helps prevent the screw from coming loose because it can't pivot at all, which would, of course, loosen the screw. So it's going to be a completely stonewashed, really nice engine, I think. But oh yeah, I was talking about the 7 years of learning. It's what initially got me interested in machining, where my dad was using Bobcat V21. And I asked him, there's a better look at the stonewash finish. I kind of asked him about it, and he helped me through an earlier solenoid engine than the one I showed you there that looked a bit like a 600 horsepower Snow, and that it just had two cylinders. It was supposed to be double acting, but it turned out not to be. Big flywheel, had a bearing block on this side instead of this side. It was a really fun project. My dad helped me cut out all the parts. In fact, there's probably a video on my YouTube channel of the router table in our basement cutting these parts out. And then I was like, hey, I really would like to be able to do this on my own. yeah, it was, that's how all of this came to be. That's what really got me interested in CNC. Of course, my father with the router tables, and to me that's all the CNC was. I didn't know what that probably didn't even exist yet. Yeah, the Series 1 would have existed at that time. Now I have a 770 with a ATC and all that fun stuff. And then I happened across NYC CNC just as he was getting the Tormach, I think, maybe a little bit later. I certainly remember the videos with the TIG and having absolutely no idea what any of it was. Then, of course, later on, I kind of started getting to YouTube and saw A-Bomb working on a lathe. And anyways, I'll stop rambling on that. Thank you guys for watching, and for all of the guys who have supported me throughout the years with their reviews and whatnot. I really appreciate it. See you next video.